Hey, my name's Matt Smith. I'm one of the lead members of the UVic AERO team for 2026, and we are about 3 weeks out from heading to our big student UAV competition where 15 or so universities across Canada compete in Ottawa. This year's theme is urban firefighting, and there are two primary tasks. The first day of the competition, we need to have a vehicle that's designed and capable of carrying up to 3 payload items, a radio, a oxygen tank, and a ladder, and transport it as many laps around a field as possible. Then we're going to need to drop those items at a specific drop site, and then go on to do some reconnaissance on a building that's simulated on fire. So for the day one task, we'll be using our heavyweight hexacopter, the Firefly, which has about 2.5 meter diameter and 30-inch propellers. So that's our big payload vehicle that can carry all the payloads as well as the sensors and cameras we need to do our object detection. On the second day of the competition, our task is going to be to have a vehicle that can spray targets on the outside and inside of a building. It's going to need to do some reconnaissance around the building, find those targets, spray them with water, and be able to take pictures of them and upload them to a cloud drive. We're going to have to demonstrate at least one of these targets autonomously to get full points. So that involves autonomous positioning from over 5 meters away, flying the drone up to the target that it detects. Then it'll have to position itself so it can spray the target, take a photo after it's sprayed, and upload that all as one autonomous process. Those are the tasks. Those are the vehicles we've built this year. We're going to be doing a ton of field testing over the next couple weeks. Very excited for that. Definitely going to be a highlight of the program here at UVic. All right, sick. We're out here for flight day a couple days before we leave to competition, and we're doing a full end-to-end test of the autonomous flight system on our urban firefighting drone. So we got our ground station set up here. We're running a point-to-point protocol, which lets us connect to our Raspberry Pi over this radio link here. And we're just gonna connect to that. Now we also have our ground station software letting us monitor the telemetry of the vehicle. We've essentially trained a AI YOLO model on these paper circles to detect them, and then written a program to position the drone as close to the target as we want before spraying it, and then taking a photo, uploading it. We've been in the field for how many hours now?
We got to the school at 6:30, so
AM.
roughly 14.
Nice. New PR perhaps. And we're about to launch our sprayer drone, the Cicada. We got the water mounted up already. This was the first thing we tried to do today about 14 hours ago, and it failed. We ended up going through an insane amount of troubleshooting. Classic engineering. Just nothing decides to work 3 days before your competition. So here we are again 14 hours later. Round 2, baby. So our system's detecting the target with the YOLO model that we trained on 500 images. And once the target is acquired, the system uses the LiDAR data and error between the object and the center of the nozzle to move the drone towards the target on all 3 axes till a threshold is reached and it starts to spray. All right, Alex, how are you feeling?
Feeling better.
Sub 24 hours before the comp.
Yeah.
Or before we leave.
I'm gonna stress him out, don't worry.
I'm feeling better. It looks less sketch than in the beginning.
Oh, great.
Alex will come back an alcoholic after this trip.
Ready? Are we packed?
No.
No. All right. Well, we got a 3D printer in here, which is sick. We got a bunch of battery stuff that's going to go in that checked bag. We have our Firefly, our big drone in here, all packed up with our 30-inch props. All right. So our bin is too big to fit through the x-ray, so we're taking everything out of the bin. Dude, they're so locked in. Dude, there's the drone. Holy shit.
Dude, he's gonna drop it.
This might be the first time the airport has seen two, like, I don't know, 7 foot diameter drones trying to go through their x-ray. All right, we got the package. Alex, what's the rundown on the package?
It's heavy as shit.
We got this John sent like 24 hours ago or something. Do we want to crack this puppy open?
I was gonna wait till like rather in the classroom or in the
beer
dorm.
open.
Wow, thanks for the. That's not making the cut.
Ready?
We'll see how it goes.
I have confidence.
Oh yeah, high level of confidence out here. How we feeling, Mike?
We're feeling great. I think Kevin's got this in the bag. The team's busted their butt to get here.
Yeah,
No
it's just
reason.
gonna be a good time.
It's gonna be a great time.
Dude,
It's a beautiful day.
drones are sick. We love drones.
There's a blimp over there.
There's a blimp.
It's crazy, man.
Hell yeah.
We got our ground station set up here. This is our mission planner running on this computer. This is our main telemetry for the vehicle, which we're getting over RFD radio on the Tower of Sauron here. This is our RTK GPS, which helps us boost our GPS signal. Kevin's setting up. And then this is our secondary computer that lets us SSH into our Raspberry Pi to control our autonomous scripts from there, as well as capture photos, evidence of successfully sprayed targets. All right, so for task 2, you can see we take off and immediately start going out of control. We can tell from the ground that one of the motors is spinning much slower than the rest and seem to have some sort of motor failure. Luckily, due to our hex design, we can safely land the vehicle with only 5 functional motors. So we're able to land, diagnose the problem within 10 minutes or so, and get back up to speed on our second run. Unfortunately, we only have 10 minutes left, but we're still able to go out to the scene of the fire, find 3 outdoor targets, spray them successfully, go inside the building, spray 3 more targets, and finish our task. So Alex, we just got back from comp a few days ago, and mind giving us a brief rundown?
Yeah, we just got back. It was super cool going to Ottawa and flying there. We did fly, which is more than what a lot of teams could say, because a lot of them didn't make it off the ground or came crashing back down to earth a little faster. But it was super fun watching the team bond together and have a good time. There was lots of shenanigans that went on, lots of fun stuff that we did in our dorms and throughout the whole weekend. It was great. We unfortunately hit a couple of problems on the flight line, which was kind of disappointing because it never showed up before, but we debugged, we worked, we understood what happened, and we just kind of MacGyvered our way through it, through the communication problems that we were having with the vehicle, through motor failure, through all sorts of different things that came up. But what was really nice is that we came together, we made it work, we got through the problems and those challenges that came up, and we actually made it to fly and completed the tasks that we wanted to complete. We definitely had a shot of placing high if we had not had these last minute problems, but with these complicated vehicles and pieces of equipment, they come up, it's inevitable, and it just happened to be our day. But we had great weather, we had good flying conditions, we were able to deliver equipment, we were able to find targets, we were able to spray the targets as needed, and we were able to land safely every single time, which is really cool. I think it was a great opportunity to not only for us to compete, but to see all the other teams and really connect with them. There's a lot of fun times happening between kind of hanging out with the Montreal guys and Carleton, all the other different universities. We had a fun time there, and we definitely learned a lot from the other teams' approaches and what they did, and we're excited to apply that to next year and the next vehicles that we do for this competition.